we're going to start the warm-up reviewing the Chapter 6, Lesson 2. What is the first step that we do here? Who can tell me, Liam? Do the equation in the parentheses. Yeah, we do the part in the parentheses. In the parentheses, 2 plus 14, we don't need to do that. It's 16. We all know that. What's the next step that we do? What's the next step? Lucy. Yeah, Lucy said since there's no exponent, if we're following PEMDAS, we already did the parentheses. There is no exponent, so now we have to move on to the multiplication division. Now, do I do the multiplication first?
No.
Why not? Why don't I do it first? It comes first in PEMDAS, Miles.
Because they're the same thing when it goes from left to right.
Exactly, they're the same thing. It goes from left to right. In this problem, the multiplication, it doesn't matter if you did it first, but that's not always the case, so don't think about it like that. Now, you have to go from left to right when following the multiplication division and then addition subtraction. A lot of you decided to go left to right for the rest of the problem. That's not how you do it. So, first of all, 55 divided by 11. Let me see it on your fingers. Everybody should do this. It's not hard. Basically, give me a high 5. Perfect. It is 5. We get 5 plus 7 times 16. So many of you added the 5 and the 7 first because you were still going from left to right. But we still have multiplication to do. We still have that multiplication to do. So we still have to do 7 times 16. Who can tell me what 7 times 16 is? Michelle? Let's see. You are correct. 112. So then we add 5 to it, and we get 117. A lot of you added, like I said, and you added the 5 to the 7, you got 12 and then multiplied it by the 16. So many of you got 192 as your answer. Not correct. It was not correct. So, with so many of you getting that wrong, that's why I wanted you to do this warm-up again. Okay, this next problem. First things first, let's rewrite it. So many of you just kind of try to solve it with mental math, and that's good if you can, but I still want you to rewrite it just to prevent errors. So, we have 50. I like to put parentheses when I'm plugging in my variable. 1/5. Isn't that what g is equal to? Yeah, so we just plug it in, and then the squared. If I wanted to rewrite the squared, it would be 1/5 times 1/5. Does the square apply to the 50? Does it apply to that 50? No, it's not touching that 50. It is only touching the g. And then that is then touching the 50. So, we do it in that order. What's 1/5 times 1/5? Malia?
1/25.
Perfect. It is 1/25. Then we would multiply across, or we can cross cancel. Now, what can we cross cancel here? What can we cross cancel, Andrew? So we can cross cancel the 50 and the 25. We divide it by 25. 25 divided by 25 is 1. 50 divided by 25 is 2. We across multiply. We get 2 over 1, which is equal to 2. That's it. We're now starting lesson 6.4, writing expressions. It's very similar to the last lesson, except in this case, you have to make your own expression. They're not going to give it to you. So I want you to copy this down in your notebook. When writing an expression, you have to define a variable. Defining a variable means you choose a variable. That could be a letter or a symbol. We already know that. And then you decide what it represents. You decide what it means. So for example, I picked a heart, and that represents how many students in my class are absent. How many students are absent. Notice I wrote the symbol and wrote the sentence for what that symbol means. If you just write a symbol, it doesn't mean anything. I don't know what that heart means. You need to tell me what it means for me to understand. Let's look at this problem. So the problem says it says $8 more than Ryan earned. So first we have what our words are. That's the sentence that we're gonna make. Then we'd pick a variable and define it. I'm not quite sure why they picked D. I would have picked R just because it says Ryan, but whatever. They said, let D represent the number of dollars Ryan earned. That would be a nice complete sentence if you did that. You would see let D equal or let D represent. However, I'm not gonna judge you too hard on that. If you wrote D equals Ryan's earnings, if you wrote D equals Ryan's earnings, that's still acceptable. But if you just wrote D equals Ryan, that doesn't make sense. It's not what we're talking about. So, what are Ryan's earnings equal to then? Who can tell me? What are his earnings equal to? Miles? D. They are equal to D. Then I have $8 more. What does the word more mean? What does the word more mean, Rocco? So if I'm doing it, what am I doing? I'm adding, exactly. So then I've got $8 more than Ryan earned. So I make this little bar thing. You guys don't have to do this, but it's just a good visual example. And I have D, and then I have 8. This full bar is what? What is this full bar in an equation form, in an expression form? Who can tell me? It's not that hard. It's not as hard as it looks, I'm telling you. What do we think it is, Miles?
Ryan's earnings?
Yes, but what is the expression? What are the numbers, Malia? D plus 8. D plus 8. That's the expression. Jaden, what did you write down as your expression? Romario, what did you write as your expression? The heart and the 105? How? Okay, so you made it like you did our bar box like we saw right a second ago, and you did heart and 105. That means heart plus 105 because the whole bar is adding them together. So that's not how we necessarily do this problem, but it's a good guess. What do we think? How do we think we would write this, Fernando? 105 minus the heart. Exactly. Because I have 105 total students, and if they're absent, what does that mean? If they're absent, what does that mean, Lucy? Yeah, that means they're not here. And if they're not here, it's that negative. They're not here. So we're subtracting. Adding wouldn't make sense because I only have 105 students. How can I add more students to my 105? I can't. What I want you to do is page 463, A through C. And when you finish, I want you to do D. When doing a problem, how do we know which part is going to be the variable? How do I know which part is going to be the variable, Andrew? Fernando's correct. It is the unknown. It's the one we don't know. So for that first problem, like Andrew said, it's how many points the Bulls scored. We don't know how many points. When we use a variable, it's because the variable stands for the unknown. Think about our definition we did yesterday. What could I use to simplify the unknown? What could I use to represent how many points the Bulls scored? You use just B. That's what I always do. Just because it's the first letter and it kind of makes it easier for me to look back. Of course, you could use anything you want, but I always find it easier to just use the first letter. So what could we use for the second problem? What is the unknown in this problem, first of all? What's the unknown, Hannah?
The number of feet.
Number of feet. So what variable could I use, Fernando? F. Remember, I could use anything. What's the unknown in problem C, Liam? What's the unknown? Exactly, it's the cost of the shirt, and we'll just say S for the shirt. I don't like necessarily using S all that much because it kind of looks like a 5, but as long as you can tell the difference, then go ahead and use S. So this first problem is difficult for a specific reason. How do I write this first problem? Is it going to be 4 minus B or B minus 4? What do we think? Raise your hand if you think it's 4 minus B. Raise your hand if you think it's B minus 4. The answer is B minus 4. But why is that? The 4 came first in the problem, Rocco.
Okay, so I'm going to use an example.
Okay, you're going to use an example. Exactly, Hannah. We see that word fewer than. When we see that word than, we know that it actually comes after. We know that it comes after, which is weird, but we know it comes after. And the important part is, if we were adding, is 4 plus B the same as B plus 4? Yeah. But is 4 minus B the same as B minus 4? No. As Rocco was going to say, copying me, if B was 10, 4 minus 10 is not the same as 10 minus 4. They're not the same thing. So you have to make sure that you write it in the correct order. So our answer is B minus 4. What's the answer for B? Who can tell me the answer for B? I want Matthew to tell me the answer for B. What is the answer for B, Lucy? 12 times F, which we could also write as 12F or 12F or even any of like that. Any of those styles, if you wrote it like any of those, they are all equal to one another. As long as you did the multiplication. We see that word times. Who has the answer for C? I want the answer for C, Oswaldo. He added the shirt and ate. Why did you know that we were adding? What word gave it away? Total. Total gave it away. Total tends to mean addition. So we would have shirt plus 8. Like I said before, that's the same as 8 plus shirt. When we're doing addition, it's the same thing. And we're going to learn about that property afterwards, but you might already be introduced to it. So let's look at D. This one's a little trickier. $3 more than 4 times the cost of a pretzel. Let's look at the 2 keywords. First of all, who can tell me the 2 keywords in this problem? Tell me one of them or Mario. More is one of the words, yes. Who can tell me the second one, Ben? Than. It is true. We do see that word than, and if it was subtraction, that is important too, but in this case, it doesn't matter too much. Oleg? We see times. Those are our 2 important words. Yeah, more and times. So we can follow it in this specific order because it's addition. Let's just write it out using the numbers. 3 more than 4 times the cost of a pretzel, and let's just use P. That's it. All you're doing is going through the problem and typically writing it in the direct order unless it's subtraction and we see the word than. So if we're doing it, we just go straight through the problem. I want you guys to do page 464, numbers 1 through 5. If you want more practice, please do page 459, numbers 1 through 6. It'll be beneficial. A great piece of advice to you to check your work is make up a number for your variable. Make up a number for your variable. And if you plug that in and it doesn't make sense, then you know that your problem is wrong. For example, let's look at number 2. Half as many pages as George read. Our unknown is how much George read. So I'm going to make that equal to G. Some of you wrote G minus 1/2. If George read 100 pages, is 100 minus a half the same as half of 100? Is 100 minus half the same as half minus 100? No. What is 100 minus half equal to, Hannah?
It equals 99.5.
Yeah, that equals 99.5. What is half of 100, Fernando? 50. Are those equal? No. So if you're ever unsure if your problem is correct, make up a variable, make up a number for the variable, and check it. 4 times more than Elliot saved. The unknown is what Elliot saved. Our key word is time. 4 times more money. It's just 4 times E. Half as much as George read. George, when we do half, that's the same as dividing it by 2. It's the same as dividing it by 2. The width of a box that is 4 inches less than the length. We do not know the length, so it's length minus 4 because it's 4 less than. The cost of 5 CDs. 5 CDs and, meaning plus, $12. Shaco bought a large popcorn for $3.50 and 3 medium drinks. Here it's $3.50 in a box and 3 medium drinks. Do we know? It says define a variable and write an expression for the total amount. So we know that he spent $3.50 and he bought 3, let's say, drinks, right? Exactly, we know that. Then it says 1 drink costs $1.50. We just plug in $1.50 for D. We plug in $1.50 for D because we don't know how much the price of a medium drink is. Now, this is the homework, page 465, numbers 1 through 8, but we're gonna look at 9 together. It will help you with other problems. Justin is 2 years older than 1/3 Marcella's age. Whose age don't we know? Whose age don't we know? Rafi. We do kind of know Justin's. It's a good guess. What, Daniel? We don't know Marcella's age. So, how do I write that? First of all, it says 1/3 Marcella's age. It's really simple. Lucy? Yeah. M times 1/3. And then if Justin is older, are we adding age or taking away age? If he's older, are we adding age or taking away age? Anita, we're adding age. We are not multiplying age because he's not 2 times, he's just 2 years older. That's the first part. Amy is 4 years younger than 2 times Justin's age. Now whose age don't we know? So what is the age we don't know now? Reading that next sentence. What is the age we don't know? Whose age, Rocco? In the next sentence, Amy is 4 years younger than 2 times Justin's age. Whose age don't we know in this problem? Miles? We kind of know it. It's half and half. What has it been? Justin's age. So now we have 4 years younger than 2 times Justin's age. 2 times Justin's age. 2 times Justin's age. 4 years less. She is 4 years younger, meaning 4 years less. Then find Justin and Amy's age if she is 63. If she is 63, if Marcella is 63, we just plug in 63 for Marcella's age because it says Marcella is 63. So for that first one, it'd be 63 times 1/3 plus 2 is equal to J. Then we would plug it in and we'd get J and we'd solve for 2 times J minus 4. And that's how you'd get Amy's age.